All right, my friends, moving on to ellipses. Again, this is just a review. I'll make sure that my pre-cal videos are available for anybody who needs a little bit more than what I'm providing here. So in general, I would say the equation of an ellipse centered at the origin would be something of the form x squared over some constant squared plus y squared over some constant squared equals 1. The derivation, which I will not include in this video, comes from the definition of an ellipse being the collection of all points such that the distance between that point and two fixed points, the sum of those two distances is always the same constant value. And so the derivation using the distance formula and all sorts of fun stuff ends up looking this cute when it's all said and done. Also, there's a Pythagorean identity for ellipses. Sometimes folks get really confused as to, which value should go in for A or B. Some teachers would teach two forms of ellipses, one where this says B squared and this says A squared and all sorts of stuff. I just kind of give you a general idea as to what it looks like, and then this is the Pythagorean identity. And then just make sure that whatever you put in for A squared is larger than whatever you put in for B squared. You'll know you screwed up if you get an imaginary number for C. So just to kind of keep that simple, let's just say whatever you put in for A should be bigger than your B value. And again, you'd get an imaginary value for C if you screw it up. Speaking of C, the absolute value of C is the distance between the center of the ellipse, I'll just say center, of course it's an ellipse, and the focus, and each focus, I should say, but there we go, okay. And then notice it's the letter C, and center has a C in it, and focus has a C in it, and that's supposed to help you remember that that's what C is. All right, this is a continuation from part 1. So, whoopsie. So I think we're actually on example 3. Okay, the directions are just going to be to graph. And for part A, let's give you x squared plus 9y squared equals 36. Good time to pause the video and see what you think here. Okay. So the first thing I'd recommend is get something like this into the standard form. Notice this 1. It's really important that you get that 1 there. So to get that, that's your motivation for dividing both sides by 36. I'm just going to go ahead and show the distribution of the division on the left side. So we'd end up with x squared over 36, which you could think of as 6 squared, plus y squared. The 9 and the 36 cancel. You get 4, which is 2 squared, and then equals 1. So to graph this, you don't see any evidence of shifting. So it's centered at the origin, and then since 6 is getting squared underneath x squared, that tells you to move in the x direction from the center 6 units to the right and 6 units to the left. 2 is getting squared underneath y, so you could move up 2 and down 2. Optional, some people, if you have a hard time drawing ellipses, some people draw this little boundary box. If you remember, when we get to hyperbolas, the boundary box ends up being really necessary. Ellipses, it's just kind of like, if you're horrible at drawing ellipses, then the boundary box can help you just to kind of like stay within the boundaries or the lines, essentially. Also, nobody should ever poke their eye out with an ellipse. So you should not see, essentially like at the vertices, it should be differentiable, to speak in your terms there. So no pointy, cuspy corner things anywhere, considering that these you know, we model planetary orbits with these. You don't want them to have any cusps or corners in them. Nice and roundy, nice and curvy. Okay, let's give you something a little more challenging. Part B. 36x squared plus 9y squared plus 72x minus 36y plus 63 equals 0. Now, if you think you remember how to do something like that, please do pause the video and see how it goes. You can always, you know, fast forward and skip through if you know you nailed it. So for something like this, first of all, let's talk about how we know it's an ellipse. Number one, it's in the part of the notes that says this is all ellipses, but also you can tell because the highest powered terms, first of all, you have x is degree 2, y is degree 2. That's what says this is not a parabola. And then notice that they're both positive. Also, if they were both negative, you would end up having an ellipse as well. So with that said, you're going to need to complete this square because this is going to end up being something like this, except with some shifting with the x term and the y term. So I'm going to group the x terms, and I'm also going to factor the leading coefficient out at the same time. So I'm going to have 36 times x squared plus 2x. I'm going to also group the y terms and factor out that leading coefficient on the y terms. And then I'm going to move the constant term over to the other side of the equation. All right, my friends, now we're going to complete this square. So for the x terms, divide your linear coefficient by 2, square the result, you get plus 1. It looks like I added 1, it actually added 36 ones. So I'm going to add 36 ones to the other side to keep things balanced. With the y terms, divide the linear coefficient by 2, square the result, you get 4. I actually just added 9 fours, or 36. Okay, so now what do we have? We have 36 times x plus 1 squared plus 9 times y minus 2 squared equals, okay, 72 minus 63. Is that 9? I think that's 9. Okay. And then now let's get this, the loneliest number over here. So let's divide both sides by 9. I am going to distribute the division over the addition on the left side. All right, now the 9 and the 36 cancel. We're left with 4 times the quantity x plus 1 squared, plus here the 9's cancel. You're left with y minus 2 squared equals 1. So for this problem, it would be really easy to write y minus 2 squared as just over 1 squared, but a lot of people at first get a little thrown off by the 4. So think of the 4 as 4 over 1, and think, what could I be dividing by that would be equivalent to multiplying by 4? So it's the opposite of flip and multiply, it's flip and divide. So multiplying by 4 is the same as dividing by 1/4. And then, like I said before, you could think of that as 1 squared, like so. Okay? Now, 1/4 is the same as the quantity 1/2 squared. Okay, so let's graph it. I think I should put my tick marks pretty far apart this time. Oops, up to, okay. Okay, so you have, excuse me, you basically have something that would have been the graph of x squared over 1/2 squared plus y minus, oops, sorry, I'm taking the shifts off here. If you take the shifts off, y squared over 1 squared equals 1. So you basically, this graph is this one that just got shifted to the left one and up 2. So the center would be at -1, 2. And then for your x terms, you'd go to the right half a unit, to the left half a unit. From your center, you'll go vertically up 1 unit and down 1 unit. And then you could use the boundary box, or if you trust yourself to be able to draw a decent ellipse without the boundary box, then you could always do that. There we go. All right, my friends, so that's just the basics of how to graph it. And so the next thing we need to do is just make sure that you could find the foci. So example 4. The directions are to find the coordinates of the foci for, and let's just do example 3, part B. Okay, so that's just this problem here. From last year, hopefully you recall, the foci will always be located on the major axis of an ellipse. So for part B, that would be the longer axis, which in part B is the vertical axis, okay? Just for reference, in part A, that would have been the horizontal axis, just the longer of the two. So now let's look at what's the Pythagorean identity for ellipses. It's c squared equals a squared minus b squared, and then just make sure when you use it, you're putting a bigger value in for a than you are for b. So if you look at our, standard form here, which one's bigger, 1 squared or 1/2 squared? Well, 1 squared is, so you could say c squared equals 1 squared take away the 1/2 squared. So you'd have c squared is 1 minus 1/4. Square root both sides, and you end up with plus or minus root 3 over 2. Now keep in mind the absolute value of c is the distance between the center and the focus, or I should say each focus. There we go. So if you were to come up here, the center was at the point -1, 2. So you're just going to go up root 3 over 2 from there and down root 3 over 2 from there to get to the foci. So the coordinates of this focus would be still -1, but then the y-coordinate would be 2 plus root 3 over 2. And then this focus would still have an x-coordinate of -1 because you just went straight down. And then it would have a y-coordinate of 2 minus root 3 over 2. Okay, so just to be clear, the foci would have coordinates -1 and then 2 plus or minus root 3 over 2. There we go. A super quick review, but I hope this is enough to kind of bring it back from pre-cal. Again, if not, I have more detailed videos that you're welcome to watch. Not required, but welcome to watch. Take care, everybody.